All right, so today we're going to spin up Moonshot AI's Kimi K2 model in Runpod's Instant Clusters. K2 is the largest open source model released to date, and you're going to need multiple pods to load this beast at full weight, so this will be a perfect application for the new release. So we've set up a 2 terabyte network volume already to hold the model. Before we set up a cluster, we'll just deploy a pod with whatever's available in that data center. It doesn't make sense to spend an hour's worth of cluster time to download a model when a single GPU will do. So we'll just deploy a basic PyTorch mod with that network volume attached. Download speeds can vary, but you'll want to budget at least an hour or two to download the model just in case, so you'll want to grab a coffee while this is going on. So now we're just going to connect to Jupyter Notebook on the pod by pulling down navigation and then clicking connect, and then Jupyter Lab. So now we're just going to drop a few commands in to download the model. We'll link to everything on the blog, so you can just copy and paste from there. But here it is on screen if you'd rather follow along. This is going to download the Hugging Face repo and start pulling the model. We can just skip entering the token since it's not a gated model. It'll error out, but whatever. And then we'll start downloading the model. And we are going to time skip because I don't want to make you sit through all that. And once it's done, we are done with this pod. So we are going to shut this one down and start setting up our cluster. Now we are going to instant clusters on the portal. The process is nearly identical to setting up a pod, but the only difference is now you're setting up multiple machines of fully equipped pods instead of a single pod that may only have 1 or 2 GPUs in it. So we'll go and select our network volume and then select our GPU spec. We will leave it at default to 2 machines, and then we'll scroll down and finish deploying it just as if a regular pod. And now the cluster is deployed, we can click on it and see how it's doing. Now you can think of a cluster as a container of pods, and it spins on multiple pods starting from 0. So we have 0 and 1 in this cluster. But all pods within a cluster are created equal. So there's no such thing as a master or a worker node until you define them through your code or your configuration or through some other means. So you can use whichever pod you want to be the master. You just need to keep your instructions consistent. So we'll connect to Jupyter on pod 0, then go into the terminal, and then we'll just paste a command block in. And what this is going to do is it will download all the dependencies as well as VLLM, and then define a model location in a variable. And of course, we're going to use Ray to set up the communication between the pods in our cluster. And we're going to define this node as the head node within Ray, and this is how we're going to do that. We're just pulling the IP address from the OS and defining it in a variable, and then sending that variable over to Ray. And we're done setting up this pod, so we'll move over to the next one. We'll just rearrange our tabs here to keep them straight. And we'll just go to Jupyter Notebook on node 1, and same process, we'll open up a terminal. So this block is going to install dependencies as well as VLLM. It's going to tell the node that is a worker node for Ray. It's going to tell Ray where the head node is, and then we'll start the Ray process itself. We are going back to the master node now, and then we're going to start up the VLLM server and tell it to load the model. And this is going to take a little bit. I've time skipped a couple times during this process. It's probably going to look like it hangs a couple times, but unless you see an error, you can just assume that's doing its thing. Once you start seeing load the model, though, you're pretty much home free. And you know your config's good at that point. So we're going to do one last time skip because the model will take about an hour to load from a network volume. And we'll just come back when it's done. All right, once you see application startup complete, then VLLM is ready and you are ready to start running the model. It's going to set up an API server just like any other VLLM install, but we're going to do this the easy way and just paste some code in. We're just going to send a quick hello world, and we're going to get our JSON response at the bottom. So that's how you set up Kimi K2 in instant clusters. If you'd rather run in an 8-bit, you could run in a single pod of H200s, but if you really have a sensitive use case where you don't want to take the perplexity hit for quantizing it, the instant clusters are a perfect way of running the model at full weights. But at this point, you are good to go, so happy prompting.